So hope everyone is able to see my screen. Uh, Stop me in between where you feel that questions are relevant. We can take it out. Otherwise, we can collect those questions and we will have Q&A, question and answer session at the end of this presentation. Okay. Yeah. So in agenda, I think you guys are able to see my screen. Uh, so I will be discussing about application composed of microservices, container deployment or orchestration, uh, any OS, any cloud, stateless and stateful microservices, application lifecycle management, and summary. So these are the discussion we will be doing, which will encompass around service fabric. And one more thing I would like to clear, there is one more product mostly people were using earlier, whoever were involved in bigger enterprises for deployment. That was app fabric, sorry. So app fabric was distributed intermediate storage like Memcached. So that's the different product. Still, it's being offered from Microsoft. Uh, and guys who's ever knows that don't get messed with app service with this service fabric. Okay, all right. Yeah. So we have already discussed about service fabric a bit. What is it? It is one of the products being offered from Microsoft Azure, which can be installed standalone in our data center as well. So for our data center, we have to have our either Windows server or Linux machine, and we can make a cluster. And on top of that, we can install the service fabric, uh, and it will manage all those machines, and you can deploy your applications over there. So how we will be deploying those applications and how industries are giving us best practices to be followed to deploy our application, we will be discussing in more detail. Okay, so here application composed of microservices. Without discussing microservices, I think discussing Service Fabric is useless. So that's where microservices application architecture or design uh, practice goes with any orchestration tool, either Service Fabric or Docker, Container World. If you have heard any one of those, everyone enforces you to follow the microservices. So we would like to understand what is microservices and how you can compose your one monolithic application as a microservices. So in this architecture, it's a very niche architecture. You can utilize this architecture in any application, basically web application. So earlier we were deploying our application like we were having layered approach for segregating the responsibility of business logic, and after having layers, some of the layers we were building for services, we were calling web services, and whole web services we were hosting into one web server, and the application which consumes those services we were hosting in different web server. So, uh, what was the challenge over there? So, suppose there is any change in your particular service. What you were doing, you were publishing the whole web service, and it was getting deployed. And there were chances that your change can do the cascade effect into another service because that feature was getting introduced by changing some or by adding some tables into the database or any kind of schema change in database. You were either doing the wrapper around existing web services or anyhow your new feature was getting indulged with existing web services. So that was the thread, and it and also it's required a whole SDLC process. Means you have to run through all the testing, the keyway in manual testing, automation testing, functional testing, load testing. So every uh, uh, stages you were going through for a particular feature release with monolithic web services, and there were very huge team getting involved. Even releasing that particular small feature was not easy because you have to take consideration of other existing services or implementation. So you were not too much agile as well over there, and uh, technology restriction was also there. Means if you have developed that monolithic service in Java, your new feature has to be developed in Java. You cannot develop into any another language. So, seeing all these challenges, this microservices still it's a service-oriented practice, but it's extend uh, those service-oriented practices into microservices. Means you have to design your services in mini service. Initially, the wording were coming up or floating around the industries with the mini services as well. So either you have to slice your monolithic web services into smaller services. That's the first thought process you have to put for your monolithic services. How you will be slicing? Again, for that, we are having different industry defined practices. I will be just giving overview around those as well. So accordingly, you have to slice your microservices in a number of services. It's depend upon how much granular slicing you can do, and it's depend upon lot many factors. How well you know the domain, how well you are able to segregate those services from business logic to database, and that is also the bigger challenge. Suppose you know that okay, I can slice my services, accounting, HR, or onboarding, employee management, all those services into a smaller services like employee onboarding, employee uh, deboarding, employee daily attendance management, uh, all those smaller services you can slice it. But what about your database? Are you able to do that level of segregation at database level also? Because microservices says your individual service should be responsible for whole end-to-end business implementation with the data. So that's the thought process you have to bring in, and that maturity, based on the industry practices, what we consult and we work with, it's there are three practices or approaches you can follow up. I think they have included in my slides as well. So you can either you can take one service which you know that it's a pretty easy and well understandable within the team. You can take that particular service piece and you can redesign as a microservices. Another practice says leave it monolithic services as it is. Take the any new requirement and implement it as a microservices. And the third practice says that you can design your services in a microservices way at the business level, logic level, but keep data as a centralized database, right? So that's the maturity path we have to take. So as for this slide, I'm depicting that in the cloud, whenever you deploy any enterprise scale application, follow this practice, which depicts that your services will be running in form of microservices and they can consume to any other remote service as well. And in front of all microservices, there will be API gateway. We usually say it's a web proxy, web proxy, or different cloud provider have a different offering for this API gateway. It's a pretty useful because the way our services are going to be consumed moving forward. It's a very pretty required component you have to think around because it, as you are going to decouple couple your services, one service into 50 or 100 microservices, how discovery will happen, how 100 services will get managed, right? Because there will be a lot of endpoints. How multiple version of those services I can offer, how rolling upgrade will happen. So microservices doesn't come in a single or simplified way. It comes with a lot of complexity. So you have to think upfront and design it in such a way. So API gateway will be responsible to front face for any application. Client is either your mobile application or the REST endpoint or any your client application, Windows application, web application. Uh, so all consuming endpoint will be interacting with API gateway. And if you have imposed security, then identity provider will come into the picture. And based on the authentication authorization approval, it will go and able to access the services. Yeah. And if there is any static content, you will be leveraging CDN, content delivery network. And, yeah. So for microservices, there are components, right? Service discovery and service management. So these are the parts which has been uh, getting being offered from the different cloud vendors. So here as a service fabric, right? Service fabric, it's enable us to host our microservices, right? So they offer all their platform level complexity in the form of management and service discovery. So they have taken that burden and they are offering us as a service. Uh, Not only this, Service Fabric manages the uh, machines also. So just I'm breaking that point with the discovery service and service management. This is the offering from the service fabric. We take advantage during deployment. All right. So yeah, and I would like to discuss about containers. Right. Nowadays, a lot of people are discussing about container containerization. Uh, what is it? So we initially we were hosting our applications into a particular virtual machine or standalone machine. There we were deploying our particular website either in a form of web form, web garden. If you guys are from a .NET background, you would be understanding it very clearly how to achieve into the IAS. So on one machine, we were able to host only one IAS web server, and most of the time utilization was very low, and most of the time uh, those IAS server were not able to meet the requirement. And third biggest point, as we discussed, we were not able to release uh, the features because of its structure, and we were not able to scale as per the market demands. So those were challenges to those days. Even in similar thing was in Linux world as well. So Linux container came from Linux open source platform and community. So even before Docker, we were having this concept. I think you would be knowing about one Microsoft. It's a Windows virtual emulator. Uh, that was the uh, one of the products from where they were virtualizing the applications. Same application were getting virtualized in one machine. Even after that, I have worked on software, which was the one of the product from Microsoft itself. So you were bundling, building particular application. You can sequence those applications into the server, and those applications will get history to the thin client. Like if you haven't worked, just assume like click once application. So those kind of products were there, but scalability was not at that much great compared to container. Similarly, we were having in Linux world also we were having Docker C uh, concept. We were able to segregate, but there were also challenges like uh, storage segregation from different process. Uh, so there were challenges over there also. And from networking side, we were not much efficient at that time. When, at that time, we were not having software-defined network, software-defined storage. So in era around 2012, I think this software-defined network and software-defined storage were become very popular. And is it someone wants to question? I think getting equals. Okay, all right. So from there, yeah, we were discussing about from where container got evolved and how it's got popular. So industries were having capabilities, but it was not mature enough because at that time we were not having software-defined network, software-defined storage. Earlier, it was biggest challenge. Because of that, cloud is also become a possible thing for us. Because earlier, whenever we were having network, we were having our physical switches, gateways, and all that. Then we were able to deploy our network. So that was our limitation earlier. But when software-defined storage networks came in, even most of the networking appliance became software-defined. That's where we were able to offer our whole ID in a form of service as this cloud came. So similarly, this container, uh, we are able to virtualize bare metal in form of virtual machines, and in the virtual machines, we were able to run uh, multiple processes, right? Process level isolation we were able to do, but whole process isolation and process synchronization was the biggest pain for us. Means if there were challenges, if one process uh, we were not able to limit in terms of memory, computation utilization, IOs, right? So suppose in one machine, if you are running more than two or three processes, and one process is keep on increasing memory size, there will be one stage when it will shut down the other processes. And the process management, if you have worked around it, you would be knowing that what kind of pain was there. So uh, that's how we were doing process isolation. But container, it's it came with process, directory, and memory level isolation. It's started providing this kind of isolation, and it more than one container services started running on same OS, which OS level host OS level services were started getting shared among different processes in a such a way that each and every processes uh, we have that it's running or it's having its own OS. It's not getting shared. So that's how this container came in. Okay, and just I'm giving all the overview so that you would be able to associate whole philosophy and what is the way to use service fabric, right? Because service fabric offers in a two way. Either you can deploy your application as a process or as a container. So yeah, so that's how container came in. People started running container. in a one machine, more than one container getting deployed. But it was not the only requirement because as microservices came in, we started deploying our one monolithic service into 100 to 500,000 microservices. So those services we can run in hand-picked machines, and also as uh, requirements comes up, we have to scale. We have to provide the unlimited scalability. So for that purpose, we need a platform which can support scalability of microservices deployed in form of either container or process. So that's where lot of orchestration products started coming into the picture. One of the product is Service Fabric as well, and one of the product is Kubernetes, Docker Swarm, DGOS. So these are the other products. All these products have a different use case where you can utilize for the best practices, but for general overview, all solve the similar problem. Okay, so yeah, the few names and few pointers here as we mentioned, like as a container, it's give us the flexibility to deploy and configure application. Okay, microservices, not application, I would say. Fault isolation and healing. If there is any issue with one particular service or container, it will not uh, interact with other services, and it will come up with new container or service automatically. It's secure because process level isolation and directive isolation, we were able to isolate. Upgrades upgrades were become pretty easy because if your service is running in 100 or 1,000 containers, there are base industry practices like rolling upgrade, low grade deployment, canary deployment. So all in these deployment practices are inbuilt into these products, and they take care of that way. So you don't have to uh, manage those. Scaling up and down. So this is the one of the beauty of using any orchestration. Uh, which will scale up and scale down based on the load for that particular service. And microservices get deployed in two kinds, which is stateless and with state. Right. So as name suggests, right, stateless means your services will not maintain the state. Okay, and in stateful services, your service will maintain the state of execution process inside the service. So how it will get implemented, we will discuss it more in further slide. So this slide is pretty much about giving background about container. Why I bring it? Because earlier Microsoft was not supporting container into Service Fabric, but now they are supporting service container in the Service Fabric as well. So that's where I bring it, and I thought to discuss about it. So before moving, I would like to take a pause. If you guys are having any question, clarification, I'm very happy to answer. Either you guys can ping in chat window as well, because I would like to make this session interactive, as you guys will get interact. I think we will be able to clear the cloud. Okay, all right. So I will move next. Yeah. So as I mentioned, right. So Service Fabric in the Azure world, uh, it, it's been utilized, uh, I think, since more than 6, 7 years, and serving these products into the Azure public Azure, which is most of the Azure core infrastructure is being managed on Service Fabric, uh, spanning a new VM or spanning an any service. All this gets managed from the Service Fabric. Azure Document DB, I think, yeah, they have mentioned billion transactions per week, so it's getting served from the Service Fabric infrastructure, managed infrastructure. Intune, Skype for Business, Event Hub, which is more popular in the IoT scenarios, Big and Cortana, IoT Suite, SQL, Azure SQL Database, Power BI. So these are the few of services which has been powered from Service Fabric itself. And there are 300 plus Service Fabric customers. Right? So it might be there will be more new player. Yeah, integration cloud. Uh, so this is the one uh, concept I would like to bring in to help of these platform plus application management tool. They provide you a multi-tenancy model. Means you can uh, make your infrastructure to host a different tenant or same application you can host as a dev, test, and prod in same uh, in same cluster of machines. Earlier, what we were doing, we were maintaining dev integration servers separately. Uh, that those were different clusters. SIT or any test cluster was different. Production cluster was different. But here you can have all these desegregation in a same infrastructure, right? So that's the one point I was trying to bring in. And also you can maintain multiple version of same application. There is another way of running same version, different version of same application to serve different user group. Suppose you have some of the new services you want to host for a particular reason, uh, and you want a particular reason or particular group of customers should use my 1.0, and particular group of users will use 1.2, like that. So that kind of segregation you can achieve from service replication. Okay, yeah. So again, I think we have discussed around microservices. Uh, how microservices get deployed, because once you will understand how microservices get deployed and where it runs into the infrastructure, you will be able to understand microservice service fabric uh, infrastructure, how it runs your application into infrastructure. Before moving ahead, if anyone has any question, they can ask it. Guys, say something. I don't want to be silo speaker. Okay, all right. So I will move next. Okay, yeah. So this is the microservice, right? And left side is a monolithic approach. So in monolithic approach, see, I'm having application one, okay, and it's been composed of three components, and it's getting deployed into our clustered environment. Means we were running same application into more than one boxes, its machines, to achieve high availability, right? So what happened in microservices? Here you are running your one application in three boxes where utilization and cost is too much. Here you are able to run two applications in a high availability fashion, and they are easily able to communicate each other, right? So application one composed of three components or three services here, and these three services are getting deployed in at least replication factor is 3. So one service is getting replicated in three services, three nodes. Similarly, for the other application as well. So yeah, just would like to depict here the same thing. So all two applications microservices are getting distributed across the cluster based on the replication factor, and that's how we are able to maintain high availability. Okay, so cloud services biggest service fabric. So in the cloud, people were having question. We are already having web and worker roles, right? What is the difference between cloud services and Azure Service Fabric? So in cloud services, it's nothing but the way you were deploying your application, the same way you can deploy your application into the cloud service. Is either web service or worker role, web role or worker role. So how you will be thinking around to tweaking to Azure Service Fabric. So first approach is microservices. We saw what is the benefit of using microservices. We are able to achieve the microservices, but there is in infrastructure level complexity. To nail down, we are having a lot of product. One of the product is Service Fabric, right? And here you can host your services in stateless or stateful manner, right? So yeah, so here one of your component or application is getting deployed or replicated in n number of hours. Means behind the scene, it's scale ups the VM, right? So if it is your one role, either web or worker role, if you are scaling, that means you are scaling to the new VM, which is very time consuming and costly as well. So it is uneven utilization. It's not always guarantee that if you have you have opted the web plan, which is letting you run your application into 10 virtual machine. That means either you are going to utilize that much capacity or not, but you have to pay over there. So cost is one of the also dimension to choose microservices supportive platforms. Low latency, yeah. If one of the service want to consume other service which is getting housed into another machine, there is a low latency. But in microservices, there is 80 to 90% chances that all your microservices dependency will get deployed in one particular node. So within a machine, communication will be too fast. Slow deployment, here deployment is very slow. Slow scaling and failure recovery, uh, limited failure tolerance. So if something get failures, very limited options you are getting to heal it. Yeah, in Azure Service Fabric, your one of the service is getting scattered across the node based on your replication factor. So there is no chances that your service is down, and in the most of the cases, other service call will be happen within the particular node itself. Even utilization, high density, right, fast deployment and upgrade, fast scaling, and it's very easy to heal from the failure. So if one service getting down, it will span up the new service from its replica. So yeah, so service fabric, right? So service fabric, how it has been designed, it's another point of view. So here, service fabric, container and microservices. This is the layer. Okay, and underneath it has come up with built-in capability of life cycle management, always on orchestration, programming models, health monitoring, DevOps tooling, and auto scaling. These are the infrastructure enterprise capabilities are built in with Service Fabric, and it can be ran into the dev machine, your laptop, or you can run into Azure Linux box on premises, your data center, or any Windows machine, or other cloud as well, like Amazon and AWS. Right. So the same thing here also. So it's a platform for reliable hyperscale microservices based application, and that's best. So for whatever we have discussed, all those are the motivation factor to adopt the microservice, adopt the or choose the service, Azure Service Fabric. And these are the capabilities we have already discussed. So in Azure, either you can host it in Windows server base or Linux. In on-premises, you can host in Windows server or Linux. In other hosted cloud as well, you can uh, host Linux or Windows based uh, microservices to help of Service Fabric. So develop once and deploy everywhere. That's kind of slogan they give. And yeah, so for the earlier slide, we have discussed about microservices, right? So service, how those microservices are going to be deployed into the service fabric clusters of VM. That flow I'm going to explain here. So we are having two application, and these application consist of application one consists of three microservices. Application two consists of three microservices. So yep. So as you saw that here we are having six VM, and our replication factor is three. Means each services will be running on at least three machines. They can run more than three machines also. So, so as you saw earlier, we were deploying one application, combined all those components together in which were tightly coupled and getting deployed into cluster of machines. But here it's totally platform decision how to scatter or how to distribute those services into the cluster. That logic has been designed into the service fabric, and they will take care of distributing your services across the cluster, right? So suppose any machine failures happen, they will take care and they will deploy those services into a new machine with the new replications. So for example, this particular nodes get failed, right? So as you are able to see, the controller will keep on doing heartbeat for each and every node. And if we saw that, okay, one node went down, it will distribute, it will, it's a responsibility to make sure that your service is running on at least three, uh, the, the three nodes, right? So here, black, purple, and green, these three services are getting down because of that node getting down. So the controller will check that where these services are not running into the cluster. It will give the instruction and deploy those services automatically without the end user intervention into another nodes. You don't have to do anything. The platform will take care of it, and it will heal another machine. And it, if one VM, if you are in the cloud, if that VM goes down, if you have designed a scale set accordingly, availability set, sorry, it will make sure that that much of VM is running for you. And once that VM comes in, the cluster manager or controller will deploy your services to those machines. Yep. So we are moving to a words programming model. If anyone has any question, I will love to take that. I heard Naveen Kumar mention that the voice is breaking. Uh, is it fine now? Naveen, okay, all right, thank you. Uh, Anyone like to have some discussion, uh, understanding, or they have some other thought around it? They can mention. At least we will make this session interactive.
Rakesh, I have a doubt. Ramesh here.
Yeah. Uh,
As you say, the microservices, it will deploy automatically on multiple VMs. I mean, do you have any limitations with microservices or VMs? Or it will take automatically, or we need to mention any limitations or something?
yep. So here are two factors we have to remember. One is uh, whenever we will design cluster for my service fabric, I have to do the sizing. Whenever we are going to run any enterprise scale application, or if I'm going to build or offer a platform where anyone can come and host their application. So at least in terms of uh, uh, my capability of data center, I will be deploying uh, n number of VMs. So I will make sure, okay, I'm going to build a cluster of 10 virtual machine. So in 10 virtual machine, uh, how many application I can deploy? What should be the benchmark, right? It's not like, you are keep on, hosting applications. There will be some limitation. So those threshold you would be having in your mind because you are going to be a provider. Otherwise, if we know that okay, I'm going to build only for my application, uh, then I know pretty well that okay, my application can serve this much of request. So I need 5 VM, and for initial five VM, at least 2 VM will be acting as a master, 3 VM will be acting as a slave. So I want my application to be replicated. At least three replication factors also depends upon how much many VMs you are taking. Suppose if you are having uh, 2 VMs, you cannot assume replication factor should be 3 for your service. So these two dependencies go hands in hand whenever you do the sizing for your cluster design. So in Service Fabric, I usually suggest this. This is for two group of users. One is for developer, and one is for infrastructure and prudence people. Basically, who's procure the machines and VMs. So these two guys will be interacting with this service fabric, and their goal will be different. If you are coming from application side, just you will be setting your requirement that I need my application to be replicated in 5 node, 6 node in initial, and for max for the load, if it's get increased, it will scale out. So what is the scale out factor? It will get a scale to the one microservices, or how it is. So just you have to think around this. Rest of the infrastructure sizing, infrastructure guy will take care during the planning session. So if you are working as an architect, you have to deal with infrastructure and application side to design your cluster. So that's how what is your role in the whole scenario. Accordingly, you will be acting. So that's where I usually suggest there are the two user group which will be coming up to the Azure Service Fabric. One are developer, one are infra. So I hope I answered how you will be concluding for your replication factor or number of VMs. Number of VM, it's depend on how bigger infrastructure you are going to provision. Application, if you are application owner, you would be knowing what is the uh, business requirement, business demand from my service. They want 100 concurrent user, you get some. So, and which are the microservices which will be requiring more replication factor. So, before reaching to the production, in your lower environment itself, based on the logging strategy or based on your dependency matrix of your microservices, how you are designing your services. I will touch base upon programming model. That's where I was starting. You will get to know that okay, this is my service which will get hit multiple times. For example, cart, right? Cart will be getting used more often compared to payment service. Even logging service will get once, but product service will get called more often because after login, people will keep on browsing services too much. So that's how you will assume, okay, for logging services, I am happy with my three replication set. For product service, where I'm listing my product, I have to replicate it at 10 node minimum. So that's how you will come up with this matrix, and just you will be configuring those replications for your services. I hope I have given our answer.
Rakesh.
Hello.
Yeah, got it, yeah, got it, Rakesh. Thank you.
Okay. Okay. All right, man. Yeah. So I'm moving to programming model. So in microservices, as we know that we can offer services in a two-way state. But during doing development, right? Either we can slice uh, one service in a microservices, or there is another design recommendation. This is actors pattern. We say Actor pattern, I won't able to delve more in this session. You can assume as a workflow, right? Or I would like to make it more simpler in each stage. So, right, uh, each actor has its own responsibility, but after doing one acting, they delegates to its responsibility to next, right? So that the next actor will perform after him. So suppose there is one dialogue he has given to another actor, and that actor will perform, and he will. It might be he will perform, give the input to another one. So that's how the actor patterns works. To complete a one request, it will go through the different smaller services. Again, behind the scene is service, but all those one request will get served from more than two, three actors or more than one actor, I would say. So that's where we call actor design pattern for microservices. You can utilize it. So yeah, these are the more details. You can read it out. Most of the things we have already discussed, right? So yeah, I think here it will be more clear. So in microservices, licensing services, mostly you will go for the web APIs where you are designing uh, web APIs, and in case scenario of service stateless, right? And web front end will come under first box, protocol gateway, like API gateway, where you want to make sure okay further call will be with HTTPS offloading or TCP or, uh, or what is the protocol. It will decide that it will be XML, SOAP, or whatever. Background worker, if you are running any web jobs kind of scenario. In statefuls, again, it's a services uh, containing partition data in stateful services, right? Which will be having state, maintaining the state of the service. For example, uh, you are running a particular web job uh, service, which is uh, caching some data, which will be getting utilized for next processing. So that's where stateful comes up. Actors, it's a short-lived action. Fire and forget. When one actor performs, it's went off, and it's another actor's responsibility. In scenario of stateless, they don't maintain their state. If you are following the actors' patterns and you are building stateful microservices, so in that scenario means each actor's state will get maintained. Anyhow, it's kind of workflow. One actor performs, and that output goes to the next actor. So, like shopping basket, conversations, users, and sensor scenario. So, in shopping basket, uh, for your shop items, it will maintain the stations and conversation. In case of you're building any applications where conversation is happening, so in that scenario, you will be using actors pattern with a stateful and users where you want to process the user specific data in that scenario and sensors. So whenever thousand of sensors used to send any data to your service, you would like to recognize that okay, this is particular device which is keep on sending me data. So these are the high level programming model and scenarios where which model you will take it. Yeah. So again, I start with the simplest, and as you will evolve or your architecture will evolve, you can reach to mature level. Yeah. Again, this is the one of the design to show for web application how you will be designing your microservices deployment architecture would be. So in your microservices world, uh, you are hosting one particular application, so that will get served from the load balancer, for example, xyz.com. That will hit to the load balancer, and you have deployed your front end also as a stateless web service. So those are getting distributed, and your business logic is also getting deployed in a stateless microservices. So individual front end will call to individual microservices, and they will be having their individual storage to store their data. And if you are having any cache, for example, to store the user session or any cross-service session management, you can leverage the cache. When the state of the any transaction or any current transaction information will get stored out of your process. That's the stateless definition. So you are storing your process uh, the process is state or information into memory out of the process into the cache. Similarly, I would like to show stateful microservices. So, in stateful microservices, for example, one service is having its own data, right? So, uh, if you are replicating one service to the multiple services, right? So, how you will make sure that each and every service which has been running on different node are having the same information. Suppose you have did the shopping from your credit card, and whenever you shop first time, it's went to first instance and it's updated your detail, right? Uh, just I'm taking this example for to explain this scenario. It's nothing related with final design. There will be a lot of debate the way I am explaining. Uh, so in second shop, right? If you are going to serve from the different service, different instance of the same service, it might be there the earlier shopping information is not there. So how you will be maintaining the cross instance replication? That is the big challenge into the stateful microservices. So there you have to think around how and how much information we can store in memory. Okay, so yeah, there is a key built-in log manager based on the primary selection. So that is the one of the uh, mechanism which makes sure that your update is getting replicated. Yeah. So service uh, types are composed of core config data vector. So whenever you design a service, right? So you have to configure your service. For example, in the service manifest. So your service, one service will be having code, config, and data. Code is your execution logic. Config will be the information that how your application will get deployed, how many instances will be getting utilized, all those scenario where the logging will happen, or where the data endpoint, or where the other service is this service is willing to communicate. And third component is data. So how this service manifest looks like, just I'm trying to showcase here. In one service manifest, this is queue service, and here the service type, you have mentioned it is queue service type, and has purchased state 2, right? And you are explaining where it is, its code is. So this is your code, which is servicehost.exe. Since you are going to run this service into the Azure Fabric, and yeah, and what is the data package name? You are giving the data package. So this is one of the sample to explain about how the service you will be uh, configured, right? So again, you will be defining one application at high level. Okay, whenever you are uh, deploying your application, you will be having application one, and in that one application, you will be having n number of microservices. So that's uh, how I'm depicting here. Means one application, three service, and its respective code config, and this application will get used for packaging, deployment, and versioning purpose. So that's how you can run your type A application in a different version, version 1, version 2, version 3 into the infrastructure. So how many version you want, you can run into the infrastructure. Yeah, service partitioning. Uh, so uh, service, you have to partition in a such way that it can scale out easily. Okay, so that's how I think at top level we have discussed about. So all those the things are here. So yeah, so P1, P2 are nothing but these are the primary, actually primary uh, service, and its respective services are running into different. So this is another a way to explain how that services are getting distributed. So whenever you are running two more nodes, automatically based on the which are node available, it will go and it will scale to those. So that again you will be able to see that okay, my P P2 is getting replicated on three nodes, and all six nodes are getting utilized for our processing. Yeah. So application lifecycle management. Uh, so how it works means you have to plan for your application. Means you are going to develop application A. How many microservices would be, and how you want to deploy all those configuration information, not configuration, at least information you will be having upfront. You will develop that application. You will test in test environment. You will deploy, and then you will maintain for their life cycle uh, management process. And it, once you will see that okay, these are the services are highly consumed, accordingly you can tweak those services. Either you can slice it again in the microservices, or you can uh, uh, deploy that particular services in more than whatever instances you are running earlier. Okay. So again, this is the high level what we can achieve uh, from this kind of orchestrator like service fabric. So application, this is application deployment service, rolling update with rollback. It's already suppose while you are deploying any service, microservice, right? So are you are deploying a full application which are having 4 or 5 microservices. So if one service are not able to deploy properly, it will roll back. It's nothing to do with old deployment, right? Whatever you have deployed, it will keep on running, and it will roll back to the old one. And strong versioning, you can uh, run more than one version of your service. Side by side support means uh, you are running the same service on two version, same service on one node with two version. So there will not be any conflict. So how it is possible? It comes up with uh, inbuilt discovery services and load balancing, placement constraints, consistent state replication framework. So these are the inbuilt capability. These are the Stratum provides. So yeah, so that's all from my side in this introductory session. If you guys are having any issue, we can uh, take some questions as per the yeah. I think we are already exceeding. So if time allows, we can take a couple of questions. Thanks all. Hope you enjoyed my session. Uh, if you guys are interested, I will be having a further session where we will deep dive into the service level.
Thank you, Rakesh, for this informative session today about Azure Service Fabric. I believe there were some questions, few questions which you already answered, and others, if you still have any queries or concerns, so I will be sharing a feedback form. You can directly feed in your question or queries with respect to the session, and I will try to make it available with Rakesh and get it answered for you. So, Rakesh, thank you again for your time and this wonderful session.
Yeah. Thanks all, and thanks, Kasam.
Thank you.